section 5.5, double angle identities. Okay, so here are our double angle identities. So double angle means 2 times the angle here inside of our argument. So you'll just need to go through these. Again, you'll be able to have this on your quizzes and your homework and your test. So you don't necessarily need to memorize it, but you need to know how to use it. Okay. So example 1, given that sine theta is equal to 8 over 17 and cosine theta is less than 0, find sine 2 theta, cosine 2 theta, and tangent of 2 theta. So first, we see sine is positive, so sine theta is greater than 0. Okay, and sine theta is positive in quadrant 1 and quadrant 2. Cosine theta is given as a negative. Okay, cosine theta is negative in quadrant 2 and quadrant 3. Okay, so this means that we are going to be working in quadrant 2. Alright, so first let's find sine of 2 theta. So sine of 2 theta is equal to 2 sine theta cosine theta. Okay, so from here. So we know what sine theta is, but we don't know what cosine theta is. So the first thing we need to do is solve for cosine theta. So we can use our Pythagorean identity of sine squared theta plus cosine squared theta equals 1. And then we'll plug in for sine. So this is the same as cosine squared theta equals 1 minus sine squared theta. So cosine squared theta is equal to 1 minus 8 over 17 squared. Okay, so that is equal to 1 minus 64 over 289. So cosine squared theta is equal to 225 over 289. Okay, so now we need to take the square root of both sides. So we have cosine theta is equal to 15 over 17. Okay, and then don't forget that we are in quadrant 2. Okay, and cosine theta is negative in quadrant 2. So this is a negative 15 over 17. Okay, so now we can plug into our formula from up here. So sine 2 theta is equal to 2 times sine theta. So sine theta is 8 over 17. And then times cosine theta, which is negative 15 over 17. So that means that sine 2 theta is equal to negative 240 over 289. Okay, the next one is to solve for cosine 2 theta. So cosine 2 theta is equal to 1 minus 2 times sine squared theta. Okay, you can use any of these. Just plug in the ones that we found. If you use this, plug in the negative 15 over 17. Here you'd have to plug in both of them, but I'm just going to use this one since we were given sine to begin with. Okay. So cosine 2 theta is equal to 1 minus 2 times 8 over 17 squared. Okay, so that gives me 1 minus 2 times 64 over 289. So if I multiply this by 2, I have 1 minus 128 over 289. So that means that cosine 2 theta is equal to 161 over 289. Okay, and then for tan 2 theta, so tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay. We don't know what tan theta is yet. We'd have to plug in sine and cosine. An alternate form would be that tan 2 theta is equal to sine 2 theta over cosine 2 theta. Okay, and if you worked out, like if I plugged in cosine 2 theta here for this formula, I would get that in the denominator. So if you plugged in other double angle identities for here, you would end up with this double angle identity. Okay, so we're going to work with this. So we have tangent 2 theta is equal to sine 2 theta, which we found as 240, negative 240 over 289. And then cosine 2 theta is 161 over 289. Okay, so I'm just going to rewrite this as multiplication times the reciprocal so that you can see that tangent 2 theta is equal to negative 240 over 161. Okay, again, for this, you could have plugged in 2 times sine theta over cosine theta over 1 minus sine theta over cosine theta squared. Okay, so this is the same formula. I just replaced tangent A with sine over cosine. Okay, or you can just do this one here. Alright, so example 2. Find the values of the 6 trigonometric functions of theta given cosine 2 theta is equal to negative 12 over 13 and theta is between 180 degrees and 270 degrees. Okay, so here we are in quadrant 3. Alright, so we are given cosine 2 theta. So we can use a formula of cosine 2 theta to find sine theta. So cosine 2 theta is equal to 1 minus 2 sine squared theta. Okay, and we're using this one because we don't know what sine theta is, so we want to use something in it that we don't know already. You could have used this one as well. You would have just had to plug in here and here for... Actually, no, you can't use this one because you don't know what cosine theta is. Okay, you only know what cosine 2 theta is. So if you use this one, you would first have to use this one to find out what cosine theta is first to plug in here. Okay, so we're going to use this one because we know what cosine 2 theta is. So if we plug that in, we can solve for sine theta. Alright, so this is going to give me, so I have negative 12 over 13 equals 1 minus 2 times sine squared theta. Okay, or 2 sine squared theta equals 1 plus 12 over 13. So I just added this to this side and then that to that side. Okay, so this gives me 2 sine squared theta equals 25 over 13. And then I'm going to divide both sides by 2 so that I have sine squared theta equals 25 over 26. Okay, and then I want to take the square root of both sides so that I can have sine theta by itself. So sine theta equals the square root of 25, which is 5, over the square root of 26. Okay, and then remember that we are in quadrant 3. So sine theta in quadrant 3 is going to be negative. Okay, so this is also can be written as negative 5 square roots of 26 over 26. Alright, so that was sine theta. Now we want to find cosine theta. okay? Because we're trying to find all 6 functions. We have cosine 2 theta, so we need to find cosine theta. So we're going to use the cosine 2 theta equals 2 cosine squared theta minus 1. Okay, so very similar to what we did over here. We're just solving for cosine now instead of sine. So negative 12 over 13 equals 2 cosine squared theta minus 1. Or 2 cosine squared theta equals negative 1 plus 12 over 13. No. I'm sorry. 2 cosine theta equals negative 12 over 13 plus 1. Okay, so 2 cosine squared theta is equal to 1 over 13. And then I'll divide both sides by 2 so that I have cosine squared theta equals 1 over 26. And then we take the square root of both sides. Okay, so the square root of 1 is 1. And then we have the square root of 26. Okay, again, we're in quadrant 3, so cosine theta is going to be negative in quadrant 3. So that's the same as cosine theta is equal to negative square root of 26 over 26. Alright, so then we want to find tangent theta. So tangent theta is equal to sine theta over cosine theta. So that's going to give me sine theta is, and I'll just use negative 5 over square root of 26. And then cosine theta would be negative 1 over square root of 26. Okay, so that gives me negative 5 over square root of 26 times square root of 26 over negative 1. This is going to give me a positive 5. Okay, so tangent theta is equal to 5. Alright, so we want to find all 6 identities. So we can use our reciprocal identities to find the 3 that we are missing. Okay, so we have sine, cosine, and tangent. We need cosecant. So cosecant theta is 1 over sine theta. Okay, so that would be negative square root of 26 over 5. Secant theta is going to be 1 over cosine. So that would be negative square root of 26. And then cotan theta is 1 over tangent, so that would be 1 over 5. Example 3. Okay, we want to verify that the following equation is an identity. Okay, so this is a difference of quotients, difference of perfect squares on the left side. So this is going to break down into cosine squared beta plus sine squared beta times cosine squared beta minus sine squared beta. Okay, so this is difference of perfect squares. This is from college algebra. A squared minus b squared equals a plus b times a minus b. Okay, so you'll need to remember how to factor from algebra in order to solve these. Okay, another identity we know is that cosine squared beta plus sine squared beta is equal to 1. So it's equal to 1. Okay, and then from the new identities that we are learning, cosine squared beta minus sine squared beta is equal to our double angle identity of cosine 2a equals cosine squared a minus sine squared a. Okay, so this whole part right here can be replaced with cosine 2 beta. So that means our answer is cosine 2 beta, which is what we were looking for. Example 4, simplify each expression. So we have 2 cosine squared 5x minus 1. Okay, so the identity here, we have cosine 2a equals 2 cosine squared a minus 1. Okay, a in this case is 5x. So that means that we have cosine of 2 times a equals 2 cosine squared of a, which is 5x minus 1. So that means that is equal to cosine of 10x. Alright, so for B, we have sine of 165 degrees times cosine of 165 degrees. Okay, so this is sine A times cosine A. Okay, they're the same angle. One of the double angle identities that we have is sine 2A is equal to 2 times sine A cosine A. Okay, but we only have this part right here. We don't have that multiple of 2. If I divide both sides by 2, I can rewrite this formula to be 1/2 times sine 2A equals sine A cosine A. Okay, so that is what we have. Okay, A is equal to 165 degrees. So that means that this is 1/2 times sine 2 times 165 degrees equals sine of 165 cosine of 165 degrees. Okay, so this is the side that we're looking at. So we have 1/2 times sine of 2 times 165. It's going to give me 330 degrees. Sine of 330 degrees is -1/2. So this is going to give me a -1/4.